Hi guys, and welcome to Physical Sciences for Year 10 of the Australian curriculum. This explanatory video we're going to be looking at the concept of elastic potential energy. Okay, so when we talk about something which is elastic basically has the potential to be stretched. Now it can be stretched and then goes back to its original shape. So obviously if I take a rubber band here, the material inside the rubber band has the ability to be stretched, and as it's stretched it will then go back to its original shape. So as a result we classify as elastic. Now obviously this is made out of rubber, but we've got lots of different types of elastic situations. Think about a bungee rope, which has got elastic cords running through the rope. You've got springs. Springs have the ability to compress or expand depending on what you want them to do, but they go back to their original shape. You think of a bow for archery. The elastic actually there is not in the string, it's actually in the bow itself. It's the ability for the bow to bend, the contours of the bow to bend, which gives it its elastic potential. By pulling back on the string, you bend the bow, so the result is that the energy, the potential energy that you've got in the bow can then be released through the arrow or the shaft so that it can be fired off with kinetic energy. But it's actually the bow that has elastic potential. And when you release the string, what happens is the string goes back to its normal shape, and then the bow goes back to its normal shape as well. So I'll try and find some good videos for you and put them up on this section to show you the concept of various elastic properties. But let's look at the idea of elastic potential. Now the thing is, it's got potential energy, because when I stretch it, at the moment that energy is stored. Now we know that if I take this rubber band and I pull it a certain distance, I am going to do work on that rubber band. I actually have to put work in order to get the potential. Just like we had with the gravitational potential energy, you had to put work in to raise an object above the ground. So that guy was going up on the bungee, he either had to climb a long ladder or went up on a lift, but work had to be done to give them that gravitational potential energy. Work has to be done on this rubber band to actually stretch it. Work has to be done on a bow to give it elastic potential energy. As soon as we release that potential energy, that energy will then be converted into another form. In most cases it's going to be possibly kinetic energy. Okay, and that kinetic energy obviously will allow an arrow to be fired from a specific point, or a spring to be used to send an object like a trigger or on a button back to its original position. Okay, so obviously the amount of work I put in will determine how much elastic potential I've got. So let's take this rubber band. Now at the moment there is no elastic potential in there because it's not been stretched. So I take it to this position here, and now I've just got it stretched. Now I've done work on it. It's not a lot of work, but I have done work on it. Now I take it to this position here. I'm doing a little bit more work. The result is that I've got more energy, more elastic potential energy. I take it to its full extension, and the result is I have done a lot of work on this, and now it is stretched to its full potential, so it's got maximum elastic potential energy. Now if I took it any further, the chances are that it would snap. Okay, as soon as it snaps, what will happen is some of that energy will go back with an ouch factor on my thumbs. And if you've ever snapped a balloon or a rubber band and it's hit your thumbs, it hurts. That's the elastic potential being released, and it's often released, as I say, back into kinetic energy. Why? Because the object wants to go back to its original state. Okay, so elastic is very, very useful in being able to allow us to store energy, and then by having that stored energy we are then able to release it at a later time. You wind up the spring of a clockwork toy, and you can convert it into kinetic energy, and it goes on at a certain amount. You jump off a bridge with a bungee cord tied around your ankles. The result is, as your mass is falling, GPE falls into kinetic energy, and then that kinetic energy and GPE stretches the rope. Eventually the rope gets to maximum extension when all that energy has been put into the elastic. The result is it then propels you back up, and so forth and so on. And what we get is this, it's all in physics we would call it dampening, that basically we decrease the amount of energy within a system over a period of time. Maximum GPE goes into maximum kinetic energy, which then goes into maximum elastic at the bottom of the jump. The result is, or the stretch of the bungee cord. So you get the idea that someone jumps off a cliff, bang, falls with kinetic energy, stretches back, then it's going to come back up, then gravity is going to grab down, stretch again, not so much energy, pulls back up, grab down, not so much, not so much, not so much, till eventually you're hanging on that rubber band, okay, or on that bungee cable. Okay, we're not going to look at any calculations with respect to elastic potential energy. For that little snippet of information, you'll obviously need to go and select physics at senior school, and but it basically works on the idea of extension. Force links to extension, and then that can then link to energy, and there's an equation for that. Okay, so in this case it's just a concept of theory and understanding the concept of elastic potential. Okay, thank you for watching, and join me again.